Hi everybody, my name is Sinan and I'm a first-year PhD student at Lappeenranta University of Technology in Finland. Today I am going to give you an overview of our work. This is a practical work implemented in the company where I work at the moment. And the method described here is used for human activity recognition in hospital environments. So let's start with human pose estimation. What is human pose estimation? It is a task of estimating or detecting certain key points on human body in images. For instance, in this image, we see 18 key points corresponding to the certain parts on the body. And the goal of pose estimation is to detect those points in images. However, there are some problems when you start training a pose model without any pre-trained model or with entirely different data distribution. First of all, the key point annotation is quite costly compared to object detection or image classification tasks in deep learning field. And in addition to that, the amount of data required to train pose model is relatively large. Good news is that there exist some solutions such as transfer learning, few shot or zero shot learning. Different from this solution, there is another way to solve the problem. The technique called is active learning. Active learning is a way of developing model iteratively. As it is seen in this figure, you start with initially labeled set to train the model. And when there is pool of unlabeled data available to annotate, you use this model to sample data from the pool and then annotate them. Finally, add those samples to your training set and resume the training. And repeat this cycle as it is needed. And what is our objective in this study? The first one is to apply active learning for human pose estimation in an online environment. Here, I would like to draw your attention to the term online environment. Online environment here refers to an environment where the data is gathered in real-time production environments. And our second goal is to propose a cost-effective hybrid sampling strategy based on uncertainty and diversity sampling. Here is our overview of our active learning cycle. This is a hybrid approach that uses both uncertainty and the diversity sampling. At the beginning, we start with initially labeled data. In our case, it was 2000 images. We train the pose model on this data set. When there is available data gathered from the production environment, we apply model uncertainty sampling to filter the images in which the model fails to detect key points. Afterwards, the features are extracted from these images by using pre-trained ResNet50 model on ImageNet. Next, the features are transferred to diversity sampling module, where we select the most dissimilar samples. Here we use approximate nearest neighbor approach to select those samples. And how we evaluate our model? We used random sampling as a baseline method and reported results with person count accuracy metric. Person count accuracy metric is basically number of correctly detected person divided by total number of person. For further details regarding each module, I encourage you to check our paper. And finally, we are at the experiment section. Here, I will give you an overview of what kind of data we used, what kind of model we implemented, and how the training procedure is conducted. So let's start with the data. The data is provided by PintaWorks, the company where I work at the moment, and the data is accurate from hospital environment, and there is some variations in the data because of the camera angles and the lighting conditions. And the data consists of grayscale images with 368 times 368 size. And we applied some augmentations to the data, such as rotation, translation, scaling, changing brightness and contrast, and blurring. The models. We choose open pose model for human pose estimation task. Here is the overview of the model. For further details, please check the open pose paper regarding the architectural details and also what kind of output it gives. In the diversity sampling module, we initially tried two different Python libraries, which are Annoy and Flan. Annoy was chosen in our case since it was faster than Flan. And I will also tell you a bit about the training details. We train the models by using TensorFlow stack, and we run 5 active learning cycles for each method, including the proposed sampling strategy and the baseline methods. And at each iterations, 1000 images are selected and labeled by an human expert or an oracle. Now let's check the test results. And here is the test results. We reported the person count accuracy with respect to the training set size at each iteration. The figure shows that the proposed method is far better than the baseline methods. We ran experiments twice for baseline methods. That was necessary for us to see the variations in random sampling. And as you can see, both of them actually are less accurate than the active learning one. And then to further test the robustness of the proposed active learning technique, we conducted test time augmentations under certain conditions, such as dark, bright, blurred, zoomed in, and zoomed out images. What is important in this figure is that the performance of the baseline method differs a lot at each iterations. For instance, when you look at the figure C, what you see is that the baseline method performs well when it is trained with 3000 samples. However, once the new samples are added and the model trained further, the performance drops significantly. That reveals the randomness of the baseline methods. You can see same pattern with zoom in and the dark images as well. On the other hand, our method is quite stable and keeps improving at each stage consistently. And we are at the discussion part. Here I will summarize the pros and the cons of our active learning cycle. Let's start with advantages. As it was presented in the test results, the method improves the pose model significantly compared to the baseline methods, and it is able to select diverse samples. However, there is few limitations with this approach. The first one is adversarial samples. These are images in which certain objects resembles a human shape. And these samples are discarded at uncertainty sampling stage since they are assumed to be detected correctly. And another failure case is with small person size and the occlusions for the pose model. Since our work has some limitations, to overcome these issues and develop the technique further, we plan to improve uncertainty and diversity sampling parts. For instance, to eliminate adversarial samples, we need to revise uncertainty sampling parts. And diversity sampling part can be improved by using hierarchical clustering and combination of both local features and visual features. Those might be image hashes. Yeah, and that brings us to the end. If you like to have more information about the work, please check our paper and feel free to contact me by email. Thank you so much for your interest and attention.